For a session produced by our underwriter, BASF, on the energy race, please welcome Eric Rohlfing, Senior Technical Advisor at ARPA-E and the Office of Policy at the U.S. Department of Energy, Heiko Urtel, CEO of BASF Toda America and Director of BASF Battery Materials North America, and here to lead the conversation, Joseph Jones, Vice President of Innovation Communications at BASF.
All right, thanks very much and good morning. I'm delighted to be here with Dr. Rohlfing, Dr. Urtel, to talk about the future of electromobility, both globally and particularly here in the United States. So we know there's lots of brilliant minds working on developing the next generation of safe, efficient, reliable energy storage systems to advance the cause of electromobility and by extension the cause of clean air. And that's one of the topics we certainly want to address today. Also, the enduring success of the internal combustion engine has set an expectation of equal, or you could argue even higher performance from electric vehicles in the future. So those are a few of the topics I'd like to discuss. And I'd like to jump right in, and Eric, I'll direct this first question to you. In terms of the adoption rates we've seen so far, so in 2017, the overall adoption rates for electrified vehicles globally in the 1.5% range of total light-duty vehicle sales. So still relatively low, and despite the fact that virtually all the major OEMs have announced reallocation of their production, new models to come with electric vehicle options, the outlook is still for relatively low overall penetration for the next several years, perhaps even for the next decade. So what is holding people back? What is holding consumers back? What is holding the adoption rate to that low level so far?
So I think if you think of a consumer and think of a choice between an EV and a conventional vehicle, there's typically three things you think about that limit their adoption. One is cost, the other is range anxiety, and the third would be charging issues. Right. On the cost side, most of the cost is associated with the battery. That's a focus of research and focus of development. I think most automotive OEMs think they'll reach cost parity with conventional vehicles in a few years. The range anxiety issue, I think, is in part kind of a hangover from the first generation of EVs. It had limited range. I think it's less of a problem now, especially in an urban environment with modern EVs and the new ones that will be coming out. And then finally, charging. We heard a little bit about that earlier this morning. I think the charging infrastructure is coming along. For people who own an EV that charge it at their own home overnight, that's not really an issue. For people that are taking a long trip, an inner city trip, that can be a challenge, and you need to plan that trip carefully and think about it. I think in the longer term, as we think more about significant EV penetration, then you have, a coupling of the transportation sector with the electrical grid in a way that's pretty complicated, and we need to think about that and plan for that carefully, not only the increased demand due to the electric vehicles on the grid, but also their potential benefits in terms of being capable for grid-scale storage. And then finally, I think, to make this a sustainable electric vehicle future, we're going to have to do a better job than we currently do now of recycling lithium batteries and their components, because it's really at a very low percentage right now. We have to do better than that.
Okay, great, thank you. Heiko, in terms of BASF and the contributions that BASF is focused on, both from a legacy perspective, the emissions catalyst, certainly a rich legacy there, but more recently in terms of advanced battery materials research for the electromobility future that we're envisioning. What will BASF bring to this table, and is it realistic that we can expect the majority of cars to be electrified in our lifetime, or even approaching 100%, or is that still very far off in the future?
All right, so indeed, providing sustainable solution to the automotive industry, that's a core value to BASF even, and with the Engelhard acquisition in 2006, we are the pioneers in providing mobile emission catalysts to the car industry, and our products, since the introduction, have helped to avoid release of roughly 1 billion ton of pollutants into the atmosphere. But now if you look to the projections on how many cars we will have by 2025, estimates around about 1.5 billion cars globally on the road. And we have more stringent emission regulations coming up and more demand for fuel economy. So there need to be different solutions in the future. And e-mobility is directly leading into that. And what BASF is doing, we are actively doing research and production of the so-called cathode active materials. Those are the materials which are coated on the positive electrode of a battery cell. They contain the lithium, the nickel, the cobalt. And with those innovations, we are right at the heart of innovation for the batteries, because they determine all the points we've been discussing. They determine the range, the lifetime, the cost. And we are developing new materials that enable the car makers to increase the range of an electric car from today, maybe 150 to 200 miles per charge, up to 400 to 600 miles per charge in the future. We are looking for recharging times 15 minutes, and obviously want to get the cost down. And this we can do by optimizing the metals which we are using, and so on and so forth. So when will we see 100% electrification on the roads? That's a very difficult question, actually. And if you look what happened in the past, 2016, we had 750,000 electric cars registered. The projections from the conservative estimates say by 2025 we have 8 to 10 million electric cars. More aggressive, maybe 15 million by 2025. Looking at 80 million cars sold overall, that's really a long way to go to have 100% electrification. But with our innovation, we try to make this happen as quick as possible.
Very good. Thank you. So Eric, I think we've heard some of the challenges you laid out and some of the other speakers today have laid out in terms of getting to this e-mobility future. Clearly, no one company, no one entity can solve all those challenges on their own. So how do you see the current state of the public-private partnership to address the e-mobility challenge? Is that where it needs to be, or is there more work to do there?
I think the answer is a resounding yes. I mean, I think this is an area of technology where the solutions that are needed are real technical challenges, and I think there's a great interaction between the public and the private sector. On the public side, I'm going to represent DOE, that's where I'm from. You know, there's a wide range of activities, fundamental materials and chemistry being done in the Joint Center for Energy Storage Research. A lot of programs in the DOE vehicle technology programs, and of course the ones I'm partial to in ARPA-E programs and projects there. And I think to complement what Heiko said about the cathode side, there's innovation on the anode side and on the electrolyte. On the anode side, we're seeing new chemistries, new materials that incorporate silicon in the graphite. And on the electrode side, I think, electrolyte side, I think the most compelling and exciting advance is solid-state electrolytes, so that we could envision in the not-too-distant future, and I won't say how distant that is, a fully solid-state lithium-ion battery, which would be just game-changing in terms of energy density, in terms of safety, eliminating the flammable electrolyte, and really reducing the amount of material you have to use to protect a battery, because it's inherently a safer battery. So.
Great. So Heiko, back to you. Clearly, in the United States, we're an innovation leader when it comes to the automotive market. But when we think about electromobility in particular, in many ways, we're trying to catch up with some of our Asian counterparts in this industry. I'm thinking China, Korea, Japan. What will it take for the U.S. to really emerge as an innovation leader in this space for the long term?
Right, I mean, that's exactly the question. US and the US industry needs to decide, do we want to be part of that race, yes or no? It's clearly led by Asia, especially by China. Europe is picking up quickly because of those CO2 regulations imposed on the car makers. And here in the US, the market is developing slowest at the moment. So this is what we clearly see. So what's needed to change it? BASF, we are well prepared to serve this industry. We are building up a global production footprint. Actually, we started with battery materials production here in the US with our production plant in Ohio. We formed a joint venture in Japan. We just recently announced another joint venture here in the US to strengthen our manufacturing footprint here on the ground. And last month, we announced our plans to build also a production plant in Europe. So there we have a global coverage of this industry, and also our research labs are distributed around the globe to really respond to it. So what needs to happen here in the US? I mean, we are providing the technical solutions to address the concerns from the end user with range and everything. But the cost is still a topic, and to really get over the hurdle and to really make it attractive for the end users to buy such cars, we also need to think about how we can support this industry and the full value chain. There's so much money to be spent, starting from the metal mining, producers like BASF, the cell producers, and also the car makers. They need to invest heavily to make this whole industry happen. And there's nothing wrong with putting some government policies to get over that bump. And exactly the same happened with emission catalysts. I mean, why can we breathe our air outside? Because there were government policies to regulate the emissions. And why not do the same with e-mobility?
Right.
No?
So it sounds like a matter of, Eric, you had a point?
I just wanted to make a point that I forgot to make in my previous question, which is that the innovation pipeline is very robust. You asked about the public. I talked about the public funding for research, but the uptake of that research is incredible in this area. And so the small companies that ARPA-E has supported with some very innovative new electrode technologies they're beating down the doors. The automotive OEMs, the battery OEMs are beating down their doors. So there's a real demand for improved technology in this area. And BASF is a part of that.
Right.
Sure.
And so it sounds to the point, proximity to customers is very important. Working on innovation vital, right?
Absolutely.
And there's also a role for government here that we can see in the future. That would certainly support this development.
Absolutely.
So 10 minutes goes by awfully quick, so I'd like to thank you very much for your insights, and please join me in thanking Eric and Heiko.
Thank you.